Hey everybody, this is Larry. This is day 17 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's farm. Today I ran a couple of miles, didn't do that much, just, hung out. Still feel a little sluggish for whatever reason, maybe I just need to sleep more. I've been taking too many naps. Life is odd. But okay. Let's just focus on today's farm. We have 2182, construct string with repeat limit. You're given a string S and an integer repeat limit. Excuse me. Construct a new string, repeat limited string, using the characters of S such that no letter appears more than repeated limit times in a row. You do not have to use all characters from S. Okay. Returns the lexicographically largest repeated string as possible. Okay. So basically, it has to be you don't have to use all of S, but do you have to use? No, okay. I guess I was just double checking whether we had to optimize for the length before we have to optimize for lexicographically longer. But it doesn't seem so, right? Like for example, if repeat limit is 1, seems like we would just use one Z. Well, one Z and then maybe a C, and actually you could probably like do it that way. But yeah, Like you would rather have an answer that is shorter, but later in the alphabet than the other thing, right? Reverse sorted. Okay, so I think in that sense then, right, it's going to be greedy. Because we don't really care about the longer string unless they're exactly the same as a prefix, right? So, yeah, I think the idea is just to, always greedily choose the character that you can. And the reason is this idea of, it's not the exchange argument, but this idea of like this prefix dominance thing. I don't know that there's a specific term for it, but this has come up quite a few times on Leetcode with respect to when it comes to lexicographically larger, right? And you can think about it this way, right? So, I mean, we can use numbers. I think it's a little bit maybe more straightforward to understand. I don't know if that's the case. But let's say you have 5-digit numbers, 2 of them, right? If the first number is a 5, and we don't care about what the other digit is. And if the second number has a 4 prefix, they're different digits, but whatever, right? Then it doesn't matter what the rest of the thing is, right? The 5 prefix is always going to be larger than the 4, no matter what the rest of the numbers is. And that's really how this greedy is built out, right? It's because of this fact that if you just optimize the first character, and because of this greedy kind of thing, is that every character you can kind of almost inductively say the same thing, right? Meaning that, okay, let's say now this one's a 5, then the next one, again, if this is an 8 and this is a 2, it doesn't matter what the rest is, the 8 is always going to win. So we always want to greedily optimize for the thing. And sometimes the only tricky part, some problems anyway, not this one necessarily, is that you have to optimize for another thing, and lexicographically is just the tiebreaker, so you have to do some funky thing. But this one, no, it seems like you just want the lexicographically later one, and as a result, like it doesn't even matter. Like what I mean by that is that you almost want to. This would be harder to construct, but you want an answer that says Z more than like a really long answer, right? It doesn't even matter. The Z will always be larger in this case, and that's what we want. So in this way, you can just greedily choose everything. And yeah, I mean, I think there are probably ways you can do this. It's just repeatedly getting the large, and yeah, I think that's really it. I think you could also, maybe the other way of thinking about it is just repeatedly. Yeah, I mean, I think that's it, right? I mean, I think the thing I'm trying to think about is just implementation. N is equal to 10 to the 5th. We have to be slightly, maybe fast, but also not a big deal if we don't, right? As long as we're not too slow, obviously, right? So, okay. So yeah, and first of all, the original input doesn't matter anymore, so maybe we'll just do like collections of counter, right? And that would be You know, and I am usually I use F for frequency, though I've been using C for counter. I don't know, maybe that's a little bit sloppy. But yeah, and then maybe I have an answer array, right? And then now, what do we want to do? I think for now I'm just going to do the naive thing, and then we'll see. Keeping in mind that the repeat limit, this part is true, but it only matters for the most character, right? What I mean by that is that you don't necessarily want like ZZZ and then YYY. No, you want ZZZ, one Y to break the repeat limit and then all the Z's again, right? Something like that. So you have to kind of be careful as well. But I think for now, I'm just going to use the 26 or alpha times n solution just because I'm a little bit lazy. But yeah, okay. So yeah, maybe we have a last character is equal to say none, and then count of the last character is 0. So I don't know. Yeah, and then now we go while not done, right? So maybe done is equal to false. We say done is equal to true. This is just a lazy loop of like, okay, then now for C in ASCII dot lower, what's it called? I feel like I should be more familiar with this. Oh no, string dot lowercase ASCII or something, right? That's a thing, right? Nope, ASCII lowercase. I always forget which way it goes. That's why I always have to like run it real quick. Okay, there you go. Right, except for we want it reversed. And maybe that's not necessarily the best, right? But okay, maybe we can, whatever. I'm just being lazy on the typing today, right? So then now, yeah, if f of c is greater than 0, and in a greedy way this is good, then what do? Well, we have two choices. One is whether it breaks the repeat limit or not. So if last is equal to c, and count is okay, let's see. If last is not equal to c, or I'm trying to do the whatchamacallit, I forget, was it modulus totem, one of them? I don't know. But the reverse thing, I've been really bad on logic lately. But yeah, or so that means that last is equal to then count plus 1 is less than or equal to repeat limit. Then we do want this character, and then we just answer that append c. You know, and then maybe last is equal to, I guess we have to special case out anyway. I mean, this part is fine, but then we have to do like, okay, if last is equal to c, count is equal, increment by 1, else count is equal to 0. So it's not as, well, maybe I need to figure out a cleaner way to write it. But yeah, but that's pretty much it. And then now we can break, right? We can break this loop, but then now done is not true, right? Or done is equal to false because we have to we may have other character do it. And that's really it though. And then at the end, we just return this thing. And that's the idea. How do I do it? Oh, I'm dumb. This isn't lower. So we just have to subtract 1 so that this isn't 1 in the infinite loop. Yeah. And that's most of the idea. Else count is equal to 1. That's all. Whoops. Off by 1. Still wrong, huh? Count should be 4. I mean, it seems like I'm just off by 1. Why? Count is equal to 0. So if last is equal to c. Oh, I don't update last. Wow, I'm just really sloppy today. My fault, friends. Last is equal to c, right? Yeah, I don't know why I'm I don't know, just very sloppy. But yeah, but the idea is mostly there though, and we can give it a go. Wow, 7.4 seconds. Today is much faster. Yeah, 22 day streak. So what's the complexity here, right? So while the while not done thing looks scary, well, this one obviously, hopefully, anyway, it's gonna be O of alpha, where alpha is the number of characters in the alphabet. Sorry, right? And every time this is done, every time done is set to false, we decrement a character from the frequency table, which means that this whole thing only happens at most of n times, right? N times because, well, eventually this will just never be true because we ran out of characters. So that's basically the idea. And so in total, this is going to be O of alpha times n, where alpha is the size of the alphabet, right? Which is 26 in this case. What I was going to say is that you can make an optimization. The big one being that here we just do a for loop. We probably can optimize this so that we can always get the max, or like iterate from the max to down, right? I guess in this case, now that I think about it, I didn't really think about it that deeply, but it seems like there are only two cases, right? One is getting the max, but if the max has too many repeat limit, then it is the second max, which is so we use a heap, will be fine. I just didn't want to think through it, honestly. But actually, you know what? Let's optimize this, unless I already did it previously with a heap, which I didn't. I did the same thing basically as today. But okay, yeah, so we can optimize this a little bit. Yeah, let's use a heap then, right? So we have heap is equal to right? So then now for k in f dot keys, we have we want to do heap and then we want to say f of k, k, right? Yeah. So we push heap. Oh, well, we have to push it into the heap, and then now here we can say, while length of h is greater than 0, then we really have two choices, right? So then max is equal to heap q hip pop of h, right? So the count doesn't really matter as long as it's greater than 0, I think, right? So yeah, and actually, I mean it. Yeah, no, I mean we stored in f anyway, so I have to sneeze real quick. Oh, y'all. Was that me one? Oh, excuse me. But yeah, what was I gonna say? Yeah. So then now, what was it? Oh yeah. So then now, we just do the same thing with last and count, even though, yeah. So if last is not equal to the max key, maybe we could just, maybe we'd even write the same way so that we keep it mostly the same, right? So if last is not equal to c, or count plus 1 is right? And this is mostly copy paste. I mean, I'm typing it out, but yeah, we append c. If last is equal to c, then else count equal to 1. Last is equal to c. This is basically exactly the same. So maybe we can refactor this, right? And then we break, right? But what happens if this is true, right? Well, if this is true, then we actually want to get the second max. So then maybe we do an else. Oops. Else. Oh, we have to actually update the heap, right? So then we just have to push back to the heap of h, f of c, and that's it. And then otherwise, f of c2 maybe is we pop it again, right? And this one we know that it is gonna be a different one, so we're always gonna start again, right? It's either one of these two, but either way, it should be okay. If it's, yeah. So then here we do again, yeah. I mean, this is why I said like maybe we can just abstract this part, but either way. And this is C2, whoops. This is why abstraction is good. I'm just basically copy pasting, and it is not great. And keeping in mind that we actually have to push both of them back. And that's pretty much it in theory. Unless it's wrong, then it will not done with it. Dun dun dun. Web. I forgot to break out this, so I guess we always break. Which means that this is kind of an awkward loop. Can we assert that this is always going to be better? I guess, yeah, I guess so. I mean, maybe this is just an if statement then. Maybe this is a little bit awkward actually. But, oh, because this brick, it now breaks out of the other one. Alright, well, I mean, I guess we can just remove this brick. I do wonder if it goes out of bounds here for removing 2 heaps. But, yeah. Another infinite loop. Why? Oh, I don't check that. I thought I was going to check it here, but then I forgot to do it, which is that we have to check that this is greater than 0 before we push it back. Otherwise, even though we are subtracting, you know, well, even though we are subtracting, we don't do enough. Yeah, so I thought that would be the case. If this is the case, then, yeah, if length of heap is greater than 0, we do this thing. Otherwise, we're done. Or if this is equal to 0, then we break and we're done. I think that's fine. Dong dong dong. If why does it not do the first? Oh, I'm dumb. The reason why this doesn't is that because if 2 things, actually the A doesn't really make sense honestly, but Dong dong dong. Well, I mean, there's definitely at least one place that this is. Oh no, I'm just being dumb. I don't know why I'm sorting by the frequency. I think I'm just so used to. I'm too used to heap problems. Actually, no, we want to sort by this, which is, yeah. Like actually, the count doesn't even matter, right? Yeah, we don't even care about the count. We just care about the key because we just want to optimize for the key. So yeah, so we have this. And then now you have the key. The count is, I mean, this thing is the only thing that matters, but we don't even care about it. I'm mixing problems in my head, and maybe I'm rushing it too much, but because I was sorting by the count. Because I don't know, I guess it's just like you do enough problems, and most problems are actually like you sort by the count because that's just like more natural. But for this one, clearly you do not sort by the count, and I just kind of went brain dead for a second. Right. Oh, and in this case, now we have a min, and of course, as a result, yeah, it goes A first is what I'm trying to say. Though this is still bad, even if it's A first, because it goes A and then it does 5 C's in a row. So even if in that case, this is very wrong. Okay, C is equal. Let me reread this. Maybe I definitely rushed this a little bit, and and this is what happens when you copy and paste. Is that like there's just a lot of risks, but okay. So what was it? But this is why during a contest you would do it the other way that I already done it, because you don't have to worry about all these things. Or I didn't think I would have to worry about it because the code is just more easier to digest. But yeah, and we have to reverse the sorting in any case because the character is too yeah, it's sorted the other way. But I'm still trying to figure out why it does 5 in a row. That's why I'm looking at it for now. Because even if, like, sure we did the order wrong, but it should have at least like broken that up. So that's why I'm a little bit confused. I guess we can just do print last C answer, right? Just see how it gets constructed. Okay, last count, not C. Okay, so A, C, C, C. And then this Z. Do I? Oh, maybe I just. Where's my answer data? Oh yeah, okay. I was just. Okay. Okay. I just. This is also what happens when you copy and paste. I just pasted the wrong thing here. Oh, I didn't paste. I just typed it in the wrong thing. But as you can see now, it is. I mean, obviously we sorted the wrong way, but that is at least correct. So then now maybe we this is actually kind of annoying that heap in Python doesn't have an easy way to do it in reverse. Actually, maybe I can. Maybe this is a time for learning. Let me ask ChatGPT, how do you use heap q with a comparator? So I feel like that's something that I don't have it quite. Use tuple for comparison, key based. Okay, that's what I was going to do, but I was hoping that I didn't have to do it that way. Use a wrapper class for, oh yeah, so I guess you can wrap it and then do a less than function, which is also kind of silly. Use functools dot, okay, so nothing I didn't know before, but I just want to see. Yeah, I mean, I guess the way that to do it is just like, okay, well, the key is going to be like minus O of A, right? So this is the sort key, or that's the number, and then we just want to do a negative version of it. And that's it, really. Yeah. And then now we have to update all these heap things. So this is K for sort key, and then we have to, and we don't have to calculate it again. I guess that part is good. Yeah, looks okay. Let's give a quick submit. Hopefully no silly mistakes. But yeah, as you can see, much faster. Wow, people are so much faster. I don't know what's wrong. Maybe I'm just am I doing it some crazy way? 10% is pretty low though. I guess you can maybe just do, I don't know. I guess you could do a smarter thing than that. But heap optimize, that's basically what I did. Maybe I'm just kind of lazy. I don't know. But yeah, you can definitely clean this up, honestly. But yeah, I don't know. That's all I have for today though. Let me know what you think. Thanks for watching. Oh yeah, and this basically now just do two heap functions. Heap of alpha, or log of alpha, which is log of 26, which is a constant if you want to think of it that way. But yeah, and this again, still we only loop all of n times, even though this looks funky. So this is, but now you have a log n or log alpha constant instead of 20 of an alpha constant, so it makes it a bit faster. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.